unit lesson 4, and in this lesson, we're going to learn how to solve log and exponential equations. Now, we've already learned how to solve an exponential equation by finding a common base, so we are going to just review that quickly, but we're all going to also learn how to figure out how to solve an equation when we can't find a common base, and how do you solve it when you have log written in it. Okay, so first let's take a look. Let's go ahead and change example one in there. That should be 16 to the 3x and not 16x cubed. So sorry about that. Let's go ahead and change it. Okay, so let's start. We're looking for a common base here. Can I rewrite 16 and 8 with a common base? Yes, I can write them both as powers of 2. So the 8 can be written as 2 to the 3rd power. And this one, x can be 2 to the 4th. And then since I already have a 3x there, I can just multiply it. And remember, our one-to-one property tells us that as long as the bases are the same, then the exponents have to be the same as well. So knowing that, we can simply just write 12 equals 3. Okay? Set them equal, solve. So x equals 1/4. And to make sure that you check to make sure it works, plug it back in. And in this case, it does. I would have 16 to the 3/4. If I take the 4 through to 16, it's 2. Cube it. I'm up to 8. Awesome. All right. So now what happens when you can't find common base? Okay. So like in this one, 15 I can't break down, and I can't write 285 as a power of 15. 15 squared is 225. 15 cubed is bigger than that. Okay. So here's where we're going to have to start using our logarithms, finding the inverse. So the end goal is we want to take that exponential and we want to move it down to ground level. In example 1, we were able to do that with a common base. Here we aren't. So what we're going to do, first things first, is you need to isolate that exponential function, meaning if there's anything on the outside being added, subtracted, multiplied, or divided, we need to move it. We don't have that in this case, so that's nice, okay? So now what we can do is take the log of each side using the commas. You can use a log base 10, you can use common log or natural log, and that's what we're going to use because that's what you'll use a lot moving forward in calculus and in your future classes. If you do a log base 10, it will work too. Log base 2 if you want, whatever, okay? So I'm going to take the natural log of each side, and it's okay to do as long as I do it to both sides of my equation. Now remember, 15 is not the base. The base is e. Natural log is log base e. We just write it as ln, log of natural base, okay? So my base is e. I don't need to write that little letter there. All right, so now, remember, we want to get that exponent down to ground level. It can't hang out up there. So if you remember, we can use our power property, and I can write this in front. So I've got 3 times x times the natural log of 15 equals the natural log of 85. Now we need to solve for x. Okay, so what ends up happening is we're kind of just doing our change of base formula here. We're taking the log of each side, and we're saying the log, well, yeah, there we go. Keep in mind, the natural log of 15 is just a number. What is it? Let's take a look. Excuse me. So if I type in and do natural log of 15, okay, it's 2.7080, blah, blah, blah. Now, we want to leave everything right now in terms of whole numbers, so I'm going to leave it as a natural log of 15. We'll do all of our calculations at the end. If I try to calculate it all right now, I'm going to get decimals, and if I round, my answer could be too far off. Okay, but this isn't some funky thing. This is just a number. So in order to get x alone, I'm going to divide both sides by the natural log of 15 times 3. Okay, so I've got x equals natural log of 285 divided by 3 times the natural log of 15. And I'm just going to type that whole thing into my calculator. Okay, no, the ln's don't cancel because remember, this is that's some number. All right, those go together. So I'm going to type that in. And I just get, so let's pull up our fraction outline. It'll make it so much easier not worrying about parentheses. So alpha y equals enter. So I'm going to type in the natural log of 285, close my parentheses, move to the bottom 3 times the natural log of 15. Hit enter. All right, now let's give us 4 decimal places and truncate, meaning cut it off. So 0.6957. All right, I want to check that. Okay, so if I plug it back in really quickly, I can do 15. It might not be perfect because we did round. That's okay. It should be close enough. 0.6957. 284.85. It's 285. If we hadn't chopped off our number, we would have gotten there. Nice. All right, so let's try some down here. If you want to pause and try these on your own, you can, okay? I'm going to work through them really quickly. So first things first, there's nothing to isolate, so I can go ahead and take the natural log now. So we've got the natural log of 3 to the x equals the natural log of 62. So really that's x natural log of 3 by using my power property to move it down. Natural log of 62, divide both sides by the natural log of 3. All right, just go ahead and type that in. All right, I'm moving you over here. Get out of here. Okay, so I've got alpha y equals, enter, the natural log of 62 divided by the natural log of 3. Oops. Helps if I go down to the basement, right? Move, thank you. Natural log of 3. 3.7566. All right, and we can check it, and it does work, just for time's sake. When it does work, okay? All right, and then the next one. All right, so once again, I don't have anything being added, subtracted, or multiplied. That minus 6 is in the exponent, so we'll deal with that later. So we're going to go ahead and do the natural log of 4 to the x minus 6 equals the natural log of 72. Move this in front. So I've got x minus 6, natural log of 4 equals the natural log of 72. All right, now I need to divide, and when I put that in front, since it was a binomial, I should have put it in parentheses. Sorry about that, to make sure I know what goes where, because this is saying x minus 6 times the natural log of 4. Excuse me. So now divide both sides by the natural log of 4, trying to get the x alone. Now we can add 6. So I've got x is equal to the natural log of 72 over natural log of 4 plus 6. That's on the outside, moving it, right, order of operations. So let's go ahead and pull that up. Alpha y equals the natural log of 72. So really I'm doing a change of base here, guys. All right? Plus 6. 9.0849. And this one does work also when you check it. I'll show you in the next one what's not yet. All right, so in this third one, this is not problem number 3. That's 3 times 6 to the x. One of my classes didn't realize that. All right, so the first thing first, I'm dividing both sides, use a different color, by 3. I need to isolate that exponential. So I've got 6 to the x equals 35. So now I have x natural log 6 equals natural log 35. So I took the log of both sides and did my already at the same time, right? X equals natural log of 35 divided by natural log of 6, 1.9842. And it does work. All right, the last one, we're going to go ahead and isolate this 5 piece. Why are we taking the log to get it down? Because the opposite of raising something to a power is taking to an x, when the variable's up there, exponential is to take the log. So we're doing the inverse. So in case you're unsure why it works, because we're doing the inverse. All right, you can do it with any base. You don't have to do natural log. You can 10. All right, do you usually do 10 or 8? Because A, they're more natural, and B, we have those ones later. You never know which one you're going to get. You may not have that log base option. So don't bank on these two. Okay, so I've got 3x, the natural log of 5 equals natural log of 6. So it's equals the natural log of 3 times natural log of 5. Let's plug that in. .9453. All right, so now we know how to solve an exponential when we can't find a common base. You can also do this if there is a common base. It'll still work out, okay? You can use it for anything. This is just you have to do it this way if you can't find one. All right, so let's take a look at going the other way now. I'm giving you a log equation. How do we solve that? We're still trying to find x. So there's 2 different methods. When you have 2 logs equal to each other, or when you have log equal to a number. When all is said and done, though, before you move on, you should not have more than 1 log on a side. So the very first thing you need to do is condense each side if you can, or condense each log. All right, in this first problem, there's nothing I can do. I have log equals log, and there are no outside exponents. This is pretty much all you're going to be looking for. All right, and then we can use the one-to-one property. It's just like with our exponents. What that's saying is if you have a log base of x equals log base b of y, assuming your bases are the same, then you can conclude that x is going to equal y, just like with our exponentials. 3 to the x equals 3 to the fourth. The bases are the same, so x is going to have to equal 4. So as long as my bases are the same, it should work out. So when that's the case, I can just go ahead and take two sides and put them equal to each other. Right? So now I solve. So subtract 2x, I get x. Subtract 4, I get -4. When I plug that back in, it won't work. So this one is a no solution. Why won't it work? How can I check that without a calculator? Because if you were to substitute a negative back in, I'm going to get a negative number here, and you cannot take the log of a negative number. 3 times -4 is -12, plus 4 is -8. So it's not the fact that x itself was negative. It was when I substituted back in, I got a negative log. Well, why doesn't that work? Let's plug it in over here and take a peek. If I substitute this back in, I basically have -8. I can't do that because here's why. If I were to change this to an exponential, my base is 3 to the -8. If no number I can raise 3 to make a -8. A negative exponent does not make a negative number. It makes a fraction. So there's no such number, no fraction, no negative, no nothing that I can make in here for x to give me a -8. So that means that whenever you get an x, if you substitute it back in, and this itself is a negative, it won't work. Okay, so I have to reject it. It's an extraneous solution. If you try to type it into your calculator, it will say non-real answer. It'll say error. All right, first example, we have the same base. It's a base 10. Doesn't really matter what the base is as long as it's the same. So I can set them equal. Solve. I get 6x equals -3, x equals -1/2. Check it. When I plug it back in over here, I get -2.5. Can't take the log of a negative number. That's a no solution. All right, my next one, same base. So I've got x squared equals 18 minus 7x. It's a quadratic. Solve a quadratic. Move everything to one side. Plus 7x minus 18 equals 0. X plus 9, x minus 2. So x equals -9 or 2. Check them. They work. If I substitute -9 back in here, -9 squared is +81. That would be 18 plus 63, which is +81. That works. If I plug 2 back in, 2 squared is 4. 18 minus 14, 7 times 2 is 4. That works. So they both work. I have two answers. Okay, so it's not the fact that x is negative. It was that when you over here, when you plug it back in, I got a negative. When I plugged -9 in this problem, it gave me a positive number, so that was okay. Right, in my third example, first time we're seeing this here, we need to condense. I cannot have more than one log on each side when I go to try to solve it, okay? So what I need to do is condense over here, meaning write it as one log. So take care of your power property first, and then either quotient or product, depending on what it is. So I can move this to the next one. So what is 6 squared going to be? 36. Yes, 36. Good job. Okay, so I base this same here to do. Really going to have log base 5 of 9. What? How did I get that? Okay, because I moved this up to 6 squared, so I had log minus log base 5 of 4. Subtraction implies when I write it as one log divide. So I have log base 5 of 36 over 4, which is 9. Okay, so that's how I got that. Now I have them condensed, and I have one log on each side, same base, so I can set them equal. 2x minus 5 equals 9. 2x equals 14. X equals 7. It works. All right, when I plug it back in, 2 times 7 is 14, minus 5 is 9. I'm good. All right, the last thing, when I have a log is equal to a number, okay? So up top, log was equal to a log. Pretty much get rid of your logs, assuming your bases are the same. It's a shortcut version of thinking about it. But over here, I don't have a log on each side. So we can't do that. We can't just set the two sides equal, okay? So the first thing I want to do, one is condense and isolate, okay? So over here, I have the same base, so that's good. There are no exponents, so I don't have to worry about my power property, but I can use my product property. So this is going to be log of x times x minus 3. Because I can multiply the two together. So let's go ahead and actually do that. So I got log of x squared minus 3x equals 1. Well, now I have a log on one side. Change it to an exponential. Exponentiate the problem. Convert it. That's all I need to do here. What's my base? My base is 10. So I've got 10 to the first, because and this will work assuming it's equal to a number because the number is your exponent. So it's not like we're going to end up with a log up there. So I've got 10 to the first equals x squared minus 3x. Well, 10 to the first is just 10. So I've got move to one side to make it negative 10. Factor x minus 5. X is equal to 5, negative 2, both. When I plug the negative 2 back in, I will get a negative 5 over here and just negative 2 there. So that one can't work. That's going to give me negatives. So just 5 is my answer. All right, we're going to skip this first one for now. It's great. You can try it on your own. You're more than welcome to. All right, let's take a look down here. Condense and isolate one log. So it should be a log equals a number. So first things first, our property, make that an exponent. So I got log of x squared minus log of 4 equals 2. My base is 10, so they're the same, so now I can divide. So I got log x squared divided by 4, because minus means divide. Now I can go ahead and change it to an exponential. My base is 10, so I've got 10 squared equals x squared over 4. So I've got 100 equals x over 4. So I've got 400. So go ahead and take the square root of both sides, which I do. I can get positive 20 or negative 20 when I take a square root. However, when you plug the negative 20 back in, that's going to give you a negative right here. So I have to reject that one. Just positive 20 will be my answer. All right, the last one, isolates. So in this case, I have the 6, move it over. So I've got log 16. It's isolated, it's condensed, there's no exponents. So I can do 2 to the 6. 2 to the 6, hold on, 4, 8, 16, 32, 64 equals 4. X equals 9. Put that back in, it will work out. All right. We are done.